These are quick additional comments in relation to the transfer of measure theorem. The comments are in response to an example which was brought to my attention by Matthew Kwon, and that's the example he suggested. If we take the function f of which maps x into x, and the function lives on 0, 1, and it's a function in which maps into R. If you consider this semi-ring in the codomain with this measure, which returns 1 for the R and the 0 for the empty set. Now, if you do the construction like this, if you recover the semi-ring in the domain and the measure in the domain, you will have the trivial semi-ring in the domain, again with the trivial measure like this, 0 and 1. Now, for this example, in fact, the part 4 doesn't work, in fact. And this is because, like, if you compute the external measure here and external measure here, you will have, I'll just give you a very quick summary of that. You will have something like this: the external measure of the subset A here in this space, or respectively the external measure of the sum subset here in this set R, will be either 0 if the corresponding subset is empty set, and it will be 1 in any other case. Of course, A here is the subset of 0, 1, and B here is a subset of the real line. So this is I'll leave it for you to check that the external measure associated with this semi-ring and the sigma additive measure, or with this semi-ring and sigma additive measure, will be exactly like this. After we identify the external measure like this, you can see that the associated Lebesgue extension sigma algebras will be, again, trivial sigma algebras like that and like that. And now the example here Matthew suggested is this: if you take the interval 0, 1, the mapping of the image of this interval 0, 1 will be 0, 1. And that's a contradiction to the way the part 4 is given right now, because on one hand 0, 1 is measurable here, so this is satisfied. On the other hand, the image, which is also 0, 1, is not measurable here, because this 0, 1 is not measurable here. So the way this part is given right now, it's not the correct way, but the fix is very obvious. The statement of the transform measure theorem should be completed with extra assumption that actually the image of your domain is the entire codomain. So there is no any dead parts of the codomain which are not involved in the mapping F. With this extra assumption, the part 4 will stand, and then this example will no longer be relevant in relation to part 4 with this extra assumption.